Hello, and welcome to the video lecture on outer joins and union joins, the other two kinds of joins we're going to cover in Chapter 7. So these are above and beyond what's going on in an equijoin. So typically what you have is an outer join. In an outer join, you want to have all of the information from one of the tables involved in the join, regardless of whether or not it actually matches up with this information in another table. So for instance, we may have customers that have never put in an order, right? So in the SQL that we've been learning so far, if we were to do an equijoin between customer and order, any customers that had not yet submitted an order would be left out of the result set. What an outer join allows us to do is an outer join allows us to say, you know what? I want to see all of my customers regardless of whether or not they've put in an order. And that can be a very useful bit of information because we want to pass along that information to our marketing team, because why on earth do we have a customer that's never put in an order? So a use of SQL right there would be to help the marketing department focus on particular customers that they should be working on because they haven't put in any orders. A union join is very, very different from both of those joins. A union join is like building a cake, a layer cake. And the reason I make that comparison is because what you're literally doing is you're taking a result set from one SQL statement that is structurally similar to another SQL statement, and you're basically stacking them on top of each other. So an example of that would be, I want to see all of my customers and all of my salespeople together. Now if I did a regular join, I would need some kind of criteria to match them up. But I don't want to match them up in any way. I simply want them combined in a list. And the way I would do that is I would use a union join. I would write a SQL statement. So the first part of it would be writing an SQL statement that would get me all of my customers. So for instance, to make this simple, they have to be structurally similar. So so each of the SQL statements has to have the same number of columns. Those columns have to have the same data types and sizes, pretty much similar, not exact. And then you'd be able to stack them one on top of the other. So for instance, and we'll go through an example in one of the lab videos, but what you would do is you would select, say, the customer name from the customer table and the salesperson name from the salesperson table. And then you could union those two together, and you would have one column in your result set that would be comprised of all of your customers and all of your salespeople. And I'll show you that as we in the video lecture to show you how to do that for the labs. But that is the and let me just show you this last figure associated with joins. So if you're into Venn diagrams, here are some Venn diagrams. So if you look at the natural join, which is again the same, we're going to say that the natural join is the same thing as an equijoin. So here's the equijoin. What the result that we get back is where the two tables values match up. So anybody on this side or anybody on this side that doesn't equal, right? So the foreign key doesn't match the primary key is going to be left out. When we do a left outer join or a right outer join, and we'll talk about that in a different video, so all records are going to be returned from one table regardless of whether or not they match. So in this case it would be customers and orders, for instance. And then we have a union join. What we're doing is we're taking all the records from both tables and stacking them on top of each other. That will be much clearer after you watch the video on the lab, how to do that. And that ends the video lecture on outer and union joins.